So welcome back to my channel. In this video we are going to discuss about the stereoisomerism in coordination compounds. In my previous video we'll discuss about structural isomerism. Now see the stereoisomerism. This stereoisomerism is again divided into geometrical isomerism and optical isomerism. So what is geometrical isomerism? Same type of molecule, the chemical formula is same, but the arrangement of atoms in three-dimensional space is different. So that is called geometrical isomerism. So this geometrical isomerism again two types, that is cis isomers and trans isomers. Cis isomers means same type of ligands are attached in same side, that is called cis isomers. Trans isomers means same type of ligands are attached in opposite side, then that is called trans isomers. Next is optical isomerism. The molecules which are non-superimposable mirror images, so the molecules are called optical isomers. Here the molecules, when they rotate plane polarized light, then the molecules are optically active. So here these optical isomerism again divided into dextro levo isomers. First we will see geometrical isomerism. So first geometrical isomerism is commonly possible in square planar complexes and octahedral complexes. First one is coordination number 6 compounds, that is octahedral complexes shows geometrical isomerism. First one is Ma6 type. So here all 6 ligands are identical, so there is no geometrical isomerism. So M means metal, A means ligands. Next type is Ma5B type. So here 5 ligands are identical, one is different. So here also geometrical isomerism is not possible. Next is Ma4B2 type. Here 4 ligands are identical and 2 is identical. So this type of compound shows geometrical isomerism. See, the example is tetraamine dichlorocobalt. See, this is the cis structure and this one is trans structure. So see the first position. See, this one is first, second, third, fourth, fifth. So if you know the positions of cis and trans position, then you can easily identify the cis isomers and trans isomers. See the positions of cis isomers, that is 1, 2, 1, 3, 1, 4, 1, 5, 6, 3, 6, 4, 6, 5, 2, 5, 2, 3, 4, 3, 3, 5. Here in this example, first and second position 2 chlorine atoms are attached in one side. So this is cis isomer. And next one is trans isomer, means positions are 1, 6, 2, 4, 3, 5. Here 2 chlorines are attached in opposite side. So first one first position and in sixth position. Next see some more example, that is tetra-aqua dichlorocobalt, and next diethylene diamine dichlorocobalt. So these are the examples of Ma4B2 type. Next one is Ma3B3 type. So here facial and meridional. Facial means 3 identical ligands occupy one face of the octahedron. See the example, that is triamine trichlorocobalt. Next one is triamine triaqua cobalt. See the picture here. These 3 amines are attached in one side. So here first, second and third position. So the distance between these 3 ligands are 90 degrees. So and position, see the positions, facial positions are 1, 2, 3 and 1, 4, 5 are facial positions. And next one is meridional. 3 identical ligands lie in one plane that bisects that octahedron. So here 2 ligands, the distance between 2 ligands are 90 degrees and next one is 180 degrees. See here the amine 1, 2. So here the distance is 90 degrees and from here to here 180 degrees. The positions are 1, 2, 6 and 1, 5, 6 are meridional positions. Next, see the MAA to B2 type. AA means symmetrical bidentate ligands. So already in my previous video I explained about bidentate ligand. Once if you don't know, please watch that video. Now see the example is diethylene diamine dichlorocobalt diaxalato diamine cobalt. So these are the examples of MAA to B2 type. So here these two chlorine atoms. See, first example is these chlorine atoms are attached in one side. So this is the cis, and here the chlorines are attached in opposite side. This is transposition. And in next type is MAA to AB type. So here this is symmetrical, and next one A means, see the example is bromo chloro diethylene diamine cobalt. So here this chlorine and bromine is attached in one side, so this is cis position. If the chlorine and bromine are attached in opposite side, this is trans isomers. Now see coordination number 4. So coordination number 4 compound shows two types of geometries, that is square planar geometry and tetrahedral geometry. So these tetrahedral complexes do not show geometrical isomerism because the attached ligands, the distance between the ligands are very less. So because of that reason these complexes do not show geometrical isomerism. Next one is square planar complexes. Here MA4 and MA3 B type do not show geometrical isomerism because the ligands are same type, so they do not show geometrical isomerism. See the one more type is, that is MA2 B2 type. So that is, see the example is diamine dichloroplatinum. Here the cis platinum used as anti-cancer drug. One more example is diamine dichlorocopper, and these two examples are MA2 B2 type. Next type is MAB2 type. AB means unsymmetrical bidentate ligands. So see the example is diglycinato-platinum is the example. Here already I told you that Na to B2 type, that is cis platinum. So this is a cis structure and this one is a trans isomerism. So here same identical ligands are attached in one side. So here chlorine and chlorine is same side. Here the chlorine is opposite side. So this is the cis and trans isomers. And next one is optical isomerism. So optical isomerism is, remember it, that the complexes has no plane of symmetry and the complexes which shows non-superimposable mirror images. So the complexes are called optical isomerism. So here the optical activity is depending on plane of symmetry, center of symmetry. If there is no plane of symmetry and no center of symmetry, so the compounds are optically active. See the example is, these compounds mirror image is this one. These two compounds are non-superimposable mirror images. So this is optical isomerism. And in octahedral complexes, some compounds shows optical isomerism. The types is MAA3 type, MAA2, AB type and AB3 type. So these are the types which shows optical isomerism. Now see here bidentate ligands. These are all bidentate ligands, and first second is symmetrical ligands and AB is unsymmetrical ligands. So these ligands, see the example of this MAA3 type and MAA2 AB type and MAB3 type. So these examples are most important. First remember these examples, then you can easily identify the which type these compounds will show. Next one is, see first one is MAA3 type. MAA3 means symmetrical bidentate ligand. See the example is diethylene triethylene diamine cobalt. So here, when the compound is placed in plane of polarized light, then it is rotate clock direction. So that's the compound is called the compound shows dextroisomerism, means the compound rotates clock direction in plane of polarized light. So that is called dextroisomer. Symbol is D or plus symbol. Next, if the compound is rotate counterclock direction, then it is called levoisomer L or minus symbol. So the molecule must lack of internal symmetry and the mirror images are non-superimposable. And next one is racemic mixture. Racemic mixture means the compounds which gives equal amount of dextro and levoisomers, then the compound is called racemic mixture. Now see this example, D form and L form. Dextro means rotate clock direction, levo means rotate counterclock directions. Okay. Next, MAA2BB type. So AA means bidentate, symmetrical bidentate ligand. Example is diethylene diamine oxalato cobalt. Here OX means oxalato. So here the mirror images I have given in one structure. So this one is the left side is, so this is D structure, this is L structure. So L means levo, D means dextro. So levo means counterclock, D means clockwise direction. Next one is do not confuse geometrical and optical isomerism. Geometrical isomerism shows cis and trans isomerism, and optical isomerism shows dextro and levo isomers. And remember that in optical isomers, they do not have plane of symmetry and center of symmetry, and the molecules shows non-superimposable mirror images. So this is the fundamental. And next see in octahedral complexes, geometrical isomerism and optical isomerism. So here Ma6 and Ma5b, these two types, they do not show geometrical and optical isomerism. In Ma4b2 they shows only geometrical isomerism, and Ma3b3 also possible in geometrical isomerism. MAA3 shows optical isomerism. MAA2AB type shows geometrical, and here only cis isomerisms are optical isomers. And Ma2B2 type square planar complexes, this is Ma2B2. So this shows geometrical isomerism. So here octahedral coordination number 6, square planar complexes coordination number 4. If you count the total number of ligands, the number is 6 means it is octahedral. If the total number of ligands, here it is 4, so this is square planar complexes. Next see in optical isomerism M. So these are the bidentate ligands. So MAA3 and AA2AB, MAA2, these are symmetrical bidentate ligands. These are shows optical isomers. And next MAB3 is unsymmetrical bidentate ligands. So these are the most important types which will come in your theory and entrance exam. And if you have any doubts, please write in the comment box, and in my next video I will give you some more important questions from these topics. And thanks for watching.